Okay, now we're going to get into graphing quadratic functions. You can always recognize a quadratic function because the highest power that's present is x squared. You'll always see a squared term as the highest power. So that's a giveaway that you're dealing with a quadratic. Now there are many different forms. There's general form and there's vertex form. And today I'm going to show you how to graph a quadratic using this vertex form. So on the screen you can see the equation for the vertex form. And just as a tip for you this time, if the value of a is positive, then the parabola or the quadratic is going to be shaped kind of like a bowl. It's going to open upwards. Some people say that if it's happy, then it's shaped like a smile. So that's a positive feeling when you feel happy, and it's going to open upwards like a smile would. But if you're sad and you're feeling negative, and if the value of a is negative, then it's going to be like a frown, and you're going to be very sad, and it's going to open downward like that. So those are my tips for you. The vertex for a parabola in this form is h comma k. So you can simply get the value of the vertex, which is that maximum or minimum point, just by looking at the values of h and k. All right, so that's my tips for you today, and I'll see you after the video's over. What I'm doing this video is show you a graph of quadratics in vertex form, and of course I need an equation in vertex form in order to do that. So here is the general format for a quadratic, which also is a parabola. You have a value of a as the coefficient, x minus h, quantity squared, plus k. Actually, probably should be minus k, but we'll just leave that alone. Anyway, so this is the general format for an equation in vertex form. So now, how do we figure out what's going on in this graph if we know that the equation is in this form? So, all right, well, a is a negative number. And when a is a negative number, that tells us that the graph of the parabola, whatever it is actually pointing down. So that's the information we can get from this first part. Here, I can see that the vertex, which is how this equation gets its name, is the point h comma k. This is the vertex point, and it's either a maximum or a minimum point. Now, I can see here that this says x minus 3, so the value of the h or x coordinate for the vertex is 3, and this value of k is 4, so this tells me that the vertex point is the point 3 comma 4, which is right here. So this vertex point is rather special in quadratics and in parabolas because the vertex is either a maximum or minimum point, and it's also a point that falls on a line of symmetry that goes through the parabola. So this, I'm representing the line of symmetry here in the graph with a dotted line. So it's not really part of the graph, but it is what I'm going to use to help me create and construct the rest of the parabola. So by analyzing the equation up here at the top, what I've been able to figure out is that the parabola is going to point downward because the value of a is negative. And I know the vertex point is h comma k, which is right here. And that's the point 3 comma 4. So now what do I do to get the rest of the points? Well, to get the rest of the points, you got to go the old-fashioned way and substitute in some values. So what I generally do is I make a little XY table like this, and I substitute values into the equation and find out what I get. So for example, one of the easiest points to substitute in is the point x equals 0. Now, if x is equal to 0, then I have 0 minus 3, which is just negative 3. And negative 3 squared is 9. So if I were to substitute 0 into the equation, I would have negative 9 plus 4. All right, now negative 9 plus 4 is negative 5. So the point 0 comma negative 5 is a point that is on my graph. And you can see I put that point right down here. Now this point 0 comma negative 5 is 3 units away from the line of symmetry. So if that's true, there should be another point for my parabola on the other side. So if this is 3 units away from this line of symmetry, there's another point for the parabola 3 units away as well, and happens to be the point 6 comma negative 5. So I'll get the same exact answer if I were to put 6 into this equation. I'll get the exact same answer. So by getting 1 point, I will actually use this line of symmetry and it'll give me 2 points instead. All right, let's pick another easy number like 1. 1's a great number. So 1 would be here, but in order to figure out what the value is, I need to put that into the equation. Now 1 minus 3 is negative 2, and I need to square it. So after I do that, I need to add 4. Now order of operations says I must square this first. So this would be negative 2 squared, which is 4. And negative 1 times 4 is negative 4. And adding 4 makes 0. So that means that the point 1 comma 0 is another point in the graph of my parabola. And since it's 2 units away from the line of symmetry, I've got another point 2 units on this side. Now, with these 5 points, I can construct a decent parabola. So I'm going to play connect the dots and make my parabola curve down on this side, play connect the dots on this side, and curve down on that side. So that is how I get the graph of my parabola. So that is graphing quadratics in vertex form. Once you have the equation in vertex form, you get a lot of information about the vertex point and the direction, whether this parabola opens up or down. And that's all I have for you. See you next time. Okay, you just watched the video on graphing quadratics, which would also be titled graphing parabolas because they have the exact same shape when you graph them. And they mean the same thing. A quadratic is a parabola if you graph it. The general form is on your screen. I recommend that you commit that to memory, so that way you can rearrange equations into that form and easily figure out whether that parabola is opening up or down, and you can also find the vertex point. So remember, the value of a is going to tell you whether that function opens upward or downward. If it's positive, the parabola is going to open up, and if it's negative, it's going to have a maximum point, but it's going to open downward. So keep that in mind. And then finally, the vertex point is the point h comma k. So once you have the equation in this format, you can just simply identify the vertex point by analyzing the equation. That's it for now, and if you need another video, just click on the one that you need, and I'll see you later.